Did everyone, does everyone have their OVA file and their virtualization software ready to go? Oh. Should have gotten emails. Multiple.
What'd you say? We're supposed to read those?
Yeah.
Well, what do we do?
On the USB drive, there's an OVA file in the SDR maker session folder that you need to use. Whoa. You should deploy that VM. It expands to somewhere between 10 and 15 gigs. So make sure you have space for it, whether it's on your local hard drive or on an external. It'll be slow on an external unless you're running USB 3. So does anyone not have that? Anyone?
It's okay. Okay, well, let's keep going.
Okay. As long as that OVA is deploying, it'll take a few minutes. We'll get started here. If you have any trouble, raise your hand. This session is going to go fast. There's a lot to it, and there's a lot of potential to run out of time. So raise your hand if you need help, and my lovely assistant will come help you.
Hey, do you have a USB key with the software? I can't find one.
I'll grab it.
Is it Pin 2 or Gen 2 or what? I might already have it.
No, it's a custom.
Okay.
So I am Ryan Adzima. This is Jake Snyder. We have... Don't stand in front of the speakers.
That's where my bag.
Our information is up there. We like to play with radios. So what you have here is the Hack RF1. This is what we're going to be working with. It's, for the most part, the entry-level device when it comes to transmit and receive. If you want just receive, as far as an SDR goes, you're going to end up with something that's $10 to $20. It's very cheap. May not have a range that you need, but you can get an up or down converter to get you there. This one is where it really starts to get interesting because we can transmit, and the range on this thing is 1 megahertz to 6 gigahertz. So we can go through anything you need. It has a pretty high sample rate, 2 million samples per second up to 20, 8-bit resolution, which it's not the best on the market, but for our purposes, it is more than enough. It's USB. It does have a powered antenna port, so if you're doing anything with GPS, very low signal, you can power that port and send out the 3.3 volt. It is SMA, so for the purposes of this session, we will not be moving away from this antenna. We're going to stay with the telescopic antenna. It's got enough sensitivity to work through pretty much the entire range that we will be working with today. You can do a lot of programming with this. The buttons you can customize, you can write your own firmware and put it on there. It's got pins inside if you pop the case apart. It's very customizable. They do make expansion packs for it. The Portapack, which is a screen, a little jog dial button, all kinds of stuff that you can take it around and have it pre-programmed to do all kinds of nefarious things. And it is open source, so if you download the schematics, you can build this yourself and customize it and mass produce a completely separate. We're working in a custom VM because it is all open source. There are a lot of dependencies, and when you're working with all of the different types of tools that we're working with, from UHF, VHF, all the way up to the ISM, all of those, and the packages we're using, it's a dependency nightmare, so we built it all for you.
So one thing I'll mention on the OVA, we should all give Ryan a huge round of applause for all the hundreds of hours he put in. he got a lot of Slack messages from me saying, hey, can you please go grab these like 10 Git repositories and build them from source and include them? And that was even up to probably last week. So
no, I think we finalized it on Friday, right?
yeah, it was.
Yeah.
So
Friday or Saturday. So this is just a couple quotes from the Slack conversations that Jake and I had. Software-defined radio is less reliable than 3D printing.
That's scary.
Yeah.
yeah.
And then there's that one.
Oh, I remember that one.
Yeah, that one happened quite a few times. So it is frustrating, but it is rewarding. It's not simple. It's not difficult. You just have to have a lot of patience and know exactly what you want to do. And I always recommend using a VM because you're going to blow it away and break something at some point. Software-defined radio is a very young technology as far as reaching the masses. So there's all sorts of issues with dependencies out there. That's it. So we're going to dive right in. You know, I didn't want to fill this up with slides. In your drive, you should have at least Lab 0, which is the setup. I'm going to have it up here on the screen. And this is going to talk about how to deploy. That's your kit. Oh, what's going on? 2 pages. No, one. All right. Let's try this again. How's it doing that? There we go. Okay, your virtual machine requirements. It's a 64-bit processor, 2 processor cores, 4 gigs of RAM. Preferred if you have the VT extensions enabled. Code profiling, optional. 3D graphics acceleration, we are doing graphics in this. Your FFTs and waterfalls are going to show up there. If you have graphics acceleration, it helps a little bit. This has a thin provision 60 gig hard drive. Like I said, it's only about 10 to 15 gigs right now. Do have your sound card attached because we're going to do some sound. Make sure you're set to USB 2.0. The OVA is already set to 2.0. There are known issues when connecting the HackRF at USB 3. It's fine if the port is USB 3, but the VM should have 2.0 compatibility. Host time synchronization and power status is optional. It just will slow itself down if you're about to run out of battery, which is always nice. This is an Ubuntu 16.04 LTS operating system. It's running LXLE as the window manager. The username is maker. The password is WLPC, all lowercase. It will auto log in. And the user has also been added to the sudoers group. So it will not ask for a password. If you intend on using this VM beyond this session, you should fix that by going in and removing this line, the no password, in your etc sudoers file. If you don't know what that means, you're probably not going to continue using this VM, and that's perfectly fine. I've added a couple commands to the bash aliases. Vim is your default editor. I removed nano, so sorry, Blake. What? So if you need to edit a file, you can type vim, and then the file name, or edit, and then the file name. Has some fancy extensions installed on the command line, so you can see where you are when you're inside Git repos. Google Chrome is your default browser. So we have set all of this up specifically and tested it on several machines in several different variations. If you must adjust the virtual machine requirements, lower the memory, disable video acceleration, things like that. That's completely fine. I don't know that it'll work. I don't know that it'll continue to work the way we designed it. So we'll do our best to help you if you have to do that, if you don't have enough resources to run it. But for this session, I tried to keep it within reason. I don't think anyone here is running a machine that has less than 4 gigs of RAM. So hopefully we won't have that issue. You should all have virtualization software. If you didn't before you got here, you should have loaded it after you got the emails. Does anyone not have the OVA loading right now? UC?
Okay. I think also OpenBox or VirtualBox, and a couple of the other ones are, and VMware Player are on the USB drive. So if you don't have it, it's there. You will be using the telescoping antenna for the entire thing today. If you notice, if you look at the inside of the telescoping antenna, there is a little metal pin that sticks out. This is SMA. This is an SMA antenna. The other antennas are RPSMA.
Now, if you ask any Wi-Fi vendor that uses this little small adapter what they're using, they'll tell you it's SMA. It is in fact not SMA, it's RPSMA.
So the other antennas, there's a small stubby cellular quad band antenna, there's a Wi-Fi antenna. They are both RPSMA, and if you hook them up, there will be no little pin to go into the HackRF. And
the HackRF has pretty good sensitivity, so you'll still see stuff show up, but it's not good for the radios to run that way.
And do not transmit that way.
Yeah, we have tested it with this antenna all the way up into 5 gigahertz, and it amazed both of us that it works really well.
Mine didn't.
Mine didn't either.
They may have shipped you some. Oh well, yeah, yours does. So some of them may have the pin, some of them may not.
That was it. Has anyone finished loading yet? Okay. So we're getting there. I'll go through the apps quick.
So we want to talk about mapping the HackRF in via USB.
Well, yeah. Yeah, so when you connect, so start unpacking your HackRF. This is a long process. Pull this one out, and then you plug it in, and you're done. When you plug it into the computer, once your virtual machine is running, it's going to ask you to connect to the primary OS or the virtual machine. And it should have a checkbox. Most of the software has a checkbox that says, always do this. Always do that. Because there are many times that we have to reset the HackRF, and it boots really quick. But if you're not paying attention or you don't have that set, it will not remap to the VM, and you'll have to go in and manually do that. And it could affect some of the scripts where it actually does reset it. Once you're into the VM, there's a bunch of tools that are installed. They're all across the top toolbar. We have LX Terminal. This is your terminal command line. GRC, which is a graphical front end to new radio. GQRX, which is an SDR receiver. It just allows us to program the radio. And record, we can't transmit from there.
No transmit out of GQRX.
We can record and play back files from there. Wireshark, we're not going to be using, but I put it in there anyway because who doesn't love Wireshark? Google Chrome, in case you need to get on the net, and then Q Spectrum Analyzer. There's also a link on the desktop called Audio Test. Once your virtual machine is up and running, just test to make sure your audio is working by launching that. It's just an embedded web page that's running on the virtual machine. Connecting the HackRF. When you first connect it, just like I said, remember this selection. So that it doesn't interfere with anything. Following the guides, all of the guides have several color-coded CLI options. So when you see blue with the yellow, that's optional. That means it's already been done. If you want to do it, you can. If you're going to do any of this on a machine that's not this VM, it's no longer optional because it's only been done in this virtual machine. The black with the green is a required command. It's part of the lab. Off limits command, that is not in any of the guides. It didn't end up in any of the guides, but it was something that if we do publish any more of these for you guys, it would be something along the lines of, you know, transmitting at full power in 2.4. You know, showing you what it could potentially do in the syntax, but not something you should do. And then CLI output, black with orange. And that's it for the setup. Is anyone still deploying?
Oh boy, okay.
Any percentages, yell out. We don't care about Blake. I'm sorry?
Okay, I'll come take a look.
Yeah. Does anyone have any questions right now before we go into,
Hold on one second.
you know, before these finish up and we get right into using it? Have we tried it with parallels? No. Neither of us have parallels. We did try with VirtualBox and Fusion. And you... Yeah. Yep. So your sound works.
Sound works.
You were on the email. I would show you right now, but I'm a little busy. Yeah.
What about a 64-bit machine instead of open a 64-bit VM?
It won't open a 64-bit VM?
According to yeah, both of these are the same thing.
Are you guys having any other difficulties in Mustang? Any other software? Sometimes they'll have DLL.
In the background, you have to like.
Jake, do you know anything about 64-bit machines not being able to run 64-bit VMs?
Yeah, there's some BIOS settings that require it.
Step and your
Okay.
alternative of what to do.
We'll get there in just a second. So. I'm working on it. I had this. And then ask him. There was that. Yeah. No, it's. I can pull it up. I can pull it up here. Yeah. You ready? Okay. You don't have sound? I mean, you won't be able to listen to the radio because we're going to do that.
Top right-hand corner.
In your.
Okay.
There you go.
I don't have nano, so I don't know how to check this.
Learn to use a real editor. Like, I specifically did that for you guys.
Oh, I know you will. Why am I being punished for it?
You're being punished because you don't have your big boy tools.
So this should say USB 2, right?
USB 2, yes.
Okay.
Okay, so
That worked. I don't know. It's an error.
yeah,
have an error?
I would
Do you
leave
have
it.
a
I didn't see any errors like that. And another one, I would leave it. If
Well,
you
when
have
I
issues,
it at 1, this isn't the little dialogue to where to put this doesn't show up.
really?
Yeah. Like, we can leave it at 1, right? Powered on. Give it a minute to do its thing. Make it full screen. Be easy. We'll wait for it to boot, right? We'll just plug this in and it should pop up. And it's not. I'm getting lights on this. I don't know if it could have a bad board or something.
Here, plug it in.
It's not booted yet.
Yeah, it's getting there. Just plug it in.
Okay.
God.
I'll plug it into the other USB port on the other side.
Here's your settings. There you go. There we go. It's there.
All right.
Let's just make sure that it always connects. Oh, okay. Okay. You're good. The email, there were emails with lists of steps before the maker sessions. Virtualization software was one of them.
So, FYI, it doesn't appear VirtualBox likes USB 2.
Okay, it's working there with his set at USB 1.1.
Oh, was it?
Yeah.
Okay, I don't know if that's.
USB.
Yeah. Well, we set it to 2.0 and it wouldn't boot the VM, so I'm having those people in Windows try using the VM player.
Okay.
So,
What's that? I would prefer Fusion, yes. It was developed in Fusion. Well, why would you use VirtualBox if you have Fusion? Anyone, I mean, who's not at the login screen, who's not connected to their HackRF? Okay, all right. When you do get in and get your HackRF connected, this is what you're going to see. You're going to open LX Terminal up at the top here. And just type in hackrf_info. Mine's not plugged in. That will spit out some info about the connected HackRF and let you see that it's working. Up in the top left, there's a little terminal icon. So you'll see bigger? Good? You good? Are you redeploying it? Are you, okay. No, that's Blake. Yeah, we're good.
He's trying, you see, but I mean, you know, it takes him so long to get.
Well, that's just because he hasn't shaved in 6 months.
It's working out. My wife finally told me.
See, I'm the one that wears the pants at home. Yeah.
Got him in a jar and, you know, carries him for
Where's Jake?
I ran VirtualBox this time. When I plugged this in, unlike the VM which prompted me, I had to go and actually say.
You had to actually say?
I had to say. And then
Okay.
It popped up as soon as I said.
Okay. Yes.
Normal that VirtualBox is just going crazy, not doing anything?
No, that's not normal. It should have done something by now.
Yeah, it's
It hasn't
running
deployed
for
at all.
least 5 minutes. And I
Yeah,
just
it looks like
started-
it's hung.
Yeah, it looks to me too, but I can see the process.
Mine took a really long time.
It didn't show any movement for a while.
Raise your hand if you're running VirtualBox.
Yes.
Okay, if you're running VirtualBox, and unlike Fusion, when you plug in the USB and Fusion prompts and says, do you want the host or you want the VM to get it? VirtualBox, you have to go tell it. So you
It's black.
tell it that USB port with Hack5 is on. That looked like what your error was.
Mm-hmm.
If I don't do any changes, the only one what I see was because you're writing on USB 2.0 that it doesn't support 2.0.
Yeah. Yeah, USB 1.1 is fine in VirtualBox there.
I'll try to see other one.
Okay. Yeah, it was built in Fusion, so Fusion we had no problems with.
So it says I got changed something in the BIOS.
The VT extensions. BIOS setup. Advanced. Try AMT options. No, that's the terminal emulator. Go back. Device configurations. There, so VTX and enable VTD too. There you go. So that's, yep, that'll do it.
Groovy.
All right. Good. All right.
On VirtualBox, it's device, USB, and then you want to choose Great Scott Gadgets HackRF1. So the VirtualBox needs to have control over that USB, so the USB comes in that way. You might have to plug and unplug it in so that it finds it again. And then the hackrf_info should pull it up for you.
Anyone left deploying? I know there's a couple over here. Okay.
Yeah. I don't think I have a typo in there. I can, so I'm trying to update the...
So go back to your tools folder. Or to the HackRF folder.
Okay.
So CD tilde. Nope. Tilde front slash.
Sorry. Is it underscore? No.
Just hit tab. There you go. Now run it.
Okay.
I think I missed that.
Some of you are loading VirtualBox. It's opening the OVA and it's taking a really long time. That's about your CPU speed.
That's it. You're done.
Thanks.
So on the firmware installation, if anyone, I know a couple of people have started moving ahead and are on the CPLD and said that they had an issue. If you look up here, that's missing. So if you So if you move into the HackRF directory, move back to the root of the HackRF directory, and then run the command again, that'll work. Yeah, you do need to reset the HackRF in between. Yeah. Yeah. So has everyone, have a lot of people started moving ahead? What? What's? Which one? Okay, okay. Mike, you had a...
Out of the Blinky directory so they can't make it, but then just have them back out and bring it back into firmware, so that'll fail. To stay in that.
Okay, yeah.
So that's an also.
Okay, thank you. Which one was that? That was... Okay. Some people have started moving on. I'm not going to slap anyone's hand if they want to move ahead. Yep, so hands-on Lab 1, if doing the updated firmware. There was a new firmware release that came out 2 weeks ago, so we do need that. Yep, that firmware is essential to the last lab. new features were added. So, but like I said, in the CPLD option, just remember to go back into the HackRF root folder. I'm sorry? In the CPLD, step 7,
step 5, at that point, we're getting directory that already exists.
Okay, so just move into the directory.
Oh, right, okay. I didn't know whether it was
Yeah, so
or something that needed to be deleted.
No. A
so
lot of it is.
It's already there, ready to go.
Yeah. So, like I said, this new firmware came out, and we updated, but we didn't rebuild it.
Are these, is this case sensitive?
That part is yes. Yeah.
Where I'm lost. Right in the part. I'm sorry, I'm just lost in what directory I'm supposed to run this from.
So in the HackRF directory, so CD // Yep.
Okay. It said run it there?
Yep. You should just be able to hit up a few times to get there. Oh, you can't see the, okay.
Grab these things.
Oh, did you go in and build the firmware?
Yeah, I mean, I did follow step by step through your guide and everything went perfect.
So go back through, it doesn't matter if you rebuild it over top, go back through and instead of doing the firmware CPU, just go into that directory. So if you scroll back, back down, when you do this part here,
right.
Instead of attaching all of that,
right.
Just go right to that file and run that.
Okay.
So go into the HackRF firmware CPLD. Mm-hmm. SP, is it CPLD or SP? CPLD.
Okay, sorry. Eyes are actually
And then, yep.
in the directory or?
Mm-hmm. You should have default in there. Go into, no, go into this, GPIO IF folder. Just hit tab.
Oh, SGPIO.
And default should be in there. Yeah, default's right there. So run that command. Yeah, just do it right there, and you should be good.
Is there a number 3 file of the PDF? Like I got
No.
0, 1. All
Nope.
right, cool.
So we're going to go through them, and we're going to make them available, but
nice.
we're going to do a follow along up on the screen. We didn't finish all of them until this weekend, so we weren't able to get them onto the drive.
Yeah, these efforts are awesome. So well done.
Thank you.
I don't know that I'm here.
Mhm.
Do you have to update the control? Just what should I do from here?
You can wait, or when we're gonna start going through, or if you open up the firmware installation document, you're free to start doing that one.
This one?
Yeah. Okay. If you want to start working on that one, that's completely fine.
Okay, but I haven't done that update the UCP. I have to check that one as well.
You have to do all of that one. Yeah, all of the firmware document.
Right here, okay.
Yeah. So, no, the next document there.
Yeah.
Yep. Yeah, this part is important for later steps.
Okay.
So we have to make sure the firmware is up to date.
Okay, how do I go from here? Just follow the instructions.
Mm-hmm.
get caught step 5. When you say make build, build's already there, so it's going to be error. They just need to go CD
Yep.
build.
Yeah.
And then after they do this, they repush the firmware. We're going to have to go back to devices and pick it again.
Okay.
Because the device.
Because it changes.
It changes.
Yep. Okay.
When we plug it in this computer,
Turns green?
Yeah.
Yep. So reset. No.
So
reconnect it to your virtual machine. See if in the settings if it's still there.
You guys.
The second one.
You got it to come up in Fusion?
Yes.
Okay. It's not.
We already changed the side of the USB ports.
And you're in VirtualBox?
Yeah.
Okay, I can't. Where's the USB connections? Can you close that menu out and then bring it back up again? I want to see changes. Okay. Go to USB settings.
I can add it right now.
Go to the, hover over the top one. Okay, go to the second one there. That one says it's available, so add that, yep. And hit OK. And is the light green?
No.
And you said it works on his?
Yeah. When we plug it in, then all the lights are green.
Can we reboot this? Just to see.
Just a couple issues we found. If I can scroll this
in HackRF
Step
info?
5, when you do the make dir build, you're already in that directory. There's already a build directory, so it's going to error. Just go to the CD build, and then you can make from there.
As long as you see that it's
After
there,
you
it has
upload
a
the
device
firmware,
ID.
if you're in VirtualBox, you have to go back and enumerate the device again. So go back into VirtualBox, set the device, and you should see it again. Same with after you run the CLPD, you're going to have to go back and tell VirtualBox that the USB is attached. Was there another one I missed?
Sure. What's up?
So I've gotten to the step, I got everything plugged in.
You're in VirtualBox? up settings. Yeah, here. There we go. So you have a green light. Yep, you're set.
Awesome. Thanks so much.
Yep.
Question when you get a chance.
What's up?
I don't get that USB descriptor. I don't know if I was supposed to.
No. This is as long as it finds it and it has all the info there.
Okay, so the firmware version is not the same as you mentioned in here. Is that correct?
Right. We're going to update to this version. Or
Hey, Ryan, do
yes.
they all need to do the blinky, or is Lab 2 superfluous?
Lab 2 is, you can pass that if you don't plan on, or if you want to do that one later. That one's just to teach you how to load custom firmware.
Okay, the only other one they have is Lab 4.
That's
so
what the
should we move
firmware
on to
was
Lab
before.
4?
Okay.
I say this is what it is after
Yep.
I went through the stuff.
So
that's
it may also show up as that. It could show up as any other thing.
Yeah, well, it says Git, but it says it's obviously 1.02. This is 1.00.
Right. Yeah. It doesn't. It may show up as anything other when you compile it from source.
Okay. Hopefully I'm okay.
So it renames it. If you did the build from that directory, you're fine.
Okay.
Is it not showing up still?
Yeah.
Do you have another USB port?
Yeah, I got two.
Okay, so it's not. Can we try this in another port? Menu here.
That's the camera, that's the smart card reader.
So it's not even seeing it.
It says captured.
Twice.
That's because it was there, now it's there. The one you mentioned, USB 2.
Well, it won't work with USB 3. It has problems with USB 3, but shouldn't with USB 1.1. Did it show up in the devices list there in Windows?
No, it's just I think it's missing that. Listed?
Do you have VMware on here?
Yeah. I have VM. Yeah.
What do you have, like workstation player or?
Yeah, workstation player as well. Should I try it down there?
Yeah, give that a try.
I pressed the reset button as the USB cannot talk.
Now it can't talk? Okay, so you just need to go back into your USB.
Here?
Under the settings. And added a device. You should see it there.
Here, I already added Great Scott. Let's remove one. It was communicating in the first.
After you do this, the USB ID changes.
Ah, okay.
So it becomes a new device.
Okay, okay. I will enable disable.
Okay, yeah.
Okay, remove it first.
Oh, just hack RF info. This is your command prompt.
Oh. There's no dollar sign.
Yeah.
After you're done, I got a question.
Well, I'm right here with going to this screen, and it gives me the error that says no file or directory. Did I?
Yeah, you have to put a tilde in front of it. Or no slash in front of it.
Oh, okay. CD.
Hit tab. Just hit tab.
Tab?
Yeah, okay, hit enter.
Ah, okay.
So I'm at the point where I'm doing the firmware, and it says that the failed
this is where CD back into the HackRF folder.
Okay, so CD.
Actually, where are you now? Yeah, so CD tilde front slash HackRF, and now run the command.
Okay. Damn it, that is a long ass command.
Just hit up. Yep. There you go.
Yeah, this is like.
Good to go.
You normally can't do that with like a Cisco control.
No, you can't.
They don't let you go over. You're not in the right.
Yep.
I'm doing this, the final step. But is that no DFU capable USB device available? I don't know.
So it doesn't look like it's in DFU mode. So now you need to attach that because it's a different device now. No. Attach it through to your VM. So go to your USB settings.
He already remember the connection.
No, not in DFU mode. It's a completely different device now.
Okay, guys. One quick thing: if you are doing the DFU mode, there's a -U missing from the command. It is not uploading firmware currently. So, it put the -U on that command when you go to load Blinky, and you should be good. So.
Oh no. I think the manual said you must unplug.
Yeah.
Run. Release. Right.
When the 3.3 volt is green, now make sure it's connected through USB. Nope, just click that one there. Yep. Okay.
It's here.
Yep.
It's here.
And then
CRC does not match.
course.
Sorry.
Dash.
I previously used.
Yep, there it goes.
Really?
Yep. Yeah, so the way that's a dash, that's a double,
Oh.
but it doesn't look that way in
Yeah,
the formatting.
yeah.
So yeah, now they're
I
blinking.
got it. Thank you.
Yep.
Ryan?
What's up?
On what mode?
Are you using
Trick
that mode?
to paste into the command prompt of the virtual box?
Yes. Control Shift C or V.
Control. I was trying that. It says let's do it. It won't do it.
Control. So if you have content copied,
Yeah.
Control Shift V
Yeah,
will paste.
Won't paste.
Do this instead. SSH to the actual VM. And then
Um,
you just use your.
Yeah, but it should work right through the terminal.
Yeah, Control, not Command.
Yeah. Control Shift V. Well, I did, but it was something I had in the, for example.
So it's Control Shift instead of Command.
When we were trying to pull it from the, see, he'll grab it here.
Yeah, I just stuck in notes here. Okay, so Command C, which is.
Oh no, you can't go across like that.
Okay, that's where.
Yeah, it's not from outside to inside. No,
You have to go-
within the VM you can. Yeah.
Okay.
So we can pull that folder up.
Odd no device error when I try to do the blinking thing. I think it might portend badly for the next step.
Release.
So when I execute this.
Yes. So if you look in the document, that's actually a double dash in front of the device.
Oh, it's a double dash in front of the device. I found the double dash in front of the
Yeah.
Okay, I got
So it doesn't come through in the formatting very clearly.
Got it. Got it. Let's try it and see what happens. Oops. Let's put that back. Let's go to the end. Let's take away the stupid pathing that I was trying.
There you go. All right.
Victory. Thank you.
Who's going?
I don't have a blinky though.
Oh, blink.
Yeah. I don't have a second directory for blinky. So you have blinky.
Mm-hmm.
I don't have a second one.
What do you have? And you did the make and everything?
Yeah.
Change the settings in the app. Hit the reset button here. And you should be able to start.
It's in the build directory, not the blinky directory. It's blinky build. It's in there. The elves and the.
What's happened then? Can I put that back in there?
If you did cd dot back and you went, or cd dot you went back a directory space, then went make doesn't work. You have to be in the build.
Right.
So this is that's not. Okay. So this is all in the build directory.
Yeah. It's not in the blinky.
Is that accurate? Or it should be?
As long as you're getting to the bin,
It is.
you should
It's
be
just-
good.
It's just
Yeah.
in a different directory. Or
I
different
don't
folder.
know. I'll have to look into
This
that
is
one.
blinky and
I think one of the processes it automatically made the folder, but I don't.
That's DSSS.
I think it was made in here, but or it was made here in the CMake. But if you go back after that, you can't do make. You have to do make from the build. Or else it fails.
Okay.
Well, they're all there. At least I know where they are.
Yeah.
Thanks.
So why don't you take that single?
Hey man, I'm trying to run our transmit, and I'm getting a kick here about the channel number.
Should be 0 to 39.
It was, right? That's the first field?
Oh, you got to do 37.
I did do 37. I got
37,
the same.
38, 39.
Thought they just like.
Yep.
Yeah, I got the same. Everything I entered is same that error.
RF info. Not Hark. Yeah, see?
Yeah, that's because I gotta reconnect it.
Yeah. Yeah, try it again. Okay, now try the command again. Back at 1. So you mistyped it somewhere. I think. Power RC5. Where are we?
Yeah, I tried to do that.
Where is that? So this is going to be your format right here.
Right.
So if you actually do PTLE or TX, and you do
copy host.
Yeah, so we go host, PTLE tool source, packets, like that. Channel number 9. Look at that. Why are you getting an error? So it's transmitting a couple of them. Do you
Well,
guys?
it kind of looked like
Packet 0. It's just packet 2 that's not. So it doesn't like.
For example, like when I ran, where's mine? I'm gonna go back to this. Yeah, so if you ran, there is output here. Like it's picking channel 37, but then it's bitching about the channel.
It's bitching about 5 simple. What is that? I wonder if. So the radio's working.
Oh, it doesn't catch call. It's just a lot of someone has. This is
We're missing something. See, it's trying to do something with these files. So it's missing a parameter in the command.
Okay.
Yeah, because it's just an example file.
Hey, you're listening to your hack RF on these guys. That's cool.
I'm trying to. We need to find our own discussion. Okay, so you gotta think that we get.
So that's your repeat right there.
That's your.
So
how many?
The 100 there
is the number of packets you're sending.
Yeah.
So what was? Where's the interval?
So you were actually doing this here interval. So you were doing like this and telling it to do another packet without all the proper information. So it was trying for channel 100.
Okay, so maybe I'm misreading this though, because I was trying to do, so you had an interval specified there.
Yep.
And you had a space with the RN for the number of times repeat the sequence, right? Oh,
When you have multiple packets. So see it there? So it's in the command. So in this, I was telling you to put that in there, and you did. That's 150. So if you have multiple packets, you can specify an R, a repeat of all of the packets. So it'll go through all of your packets and then repeat the whole sequence again. This is telling it just to do this one 150 times.
So how do I specify the interval? Like this is the interval between packets, is it not? Like, or do it on every 150 milliseconds?
Yep.
Okay, and so that's that would just be a dash interval.
Nope. So that one right there is an interval of 100 milliseconds.
It's an interval of 100 milliseconds. But aren't you telling me here that this is
Mr. Ryan Adzima. Jake, come on up.
It keeps going.
And I know everyone's like all over the map on where this is, but can you just come up and show them all the things that are possible that you've already got done, and we'll get all the rest of the labs to them so they can play as well.
Yeah, mine.
Because you got some great demos here. Yeah, don't walk in front of that.
Stay away from the speed.
All right. Which one do you want to show?
We want to start with BLE.
BLE? All right.
Do I need to get a beacon?
Do you want to start transmitting and I'll start receiving? So one of the tools that's built in there, it's the lab that you have right now, is the BTLE, RX and TX.
That doesn't go into that.
BTLE RX is a scanner. We can sit here and we can watch all the beacons that are happening right now in this room.
So I'm simulating a virtual beacon on my phone with the Estimate app, just so that there's beacons available. I don't think that's an issue. Actually, maybe it is. The other piece is because we're not using a 2.4 antenna, the range is not going to be near as good as if you were using the 2.4 antenna.
So we're not getting near as many beacons as we normally would.
But you can see my phone beaconing, Ryan's HackerF picking it up.
So this you can use if you have an environment that's location aware and you're using BLE beacons with an app and someone says the app's not working properly. How do you know if it's the beacons or the app? Well, take this, scan, make sure you see all the beacons you're supposed to in the environment. If you don't, or if you see that the interval is not going properly, you know that it could be a hardware issue on site.
So you want to do FM?
Oh, just aside, great demo of, you have a sample text of how to transmit BLEs just as well.
Yes.
Where's that host? BTLE tools source. So this file here that I'm going to it's the same format as the text document, as the guide gives you to build one. These are simulated beacons. And what you can do here is you can build it out using your UUID, your major, your minor, so you can build a specific beacon. So if you needed to clone a specific beacon in your environment, you can do that, and it would be BTLE TX and then the command. If you use a text file and you need, you can simulate multiple beacons simultaneously. So you put it all in a text file and you can simulate all the beacons in your environment and test an app or any sort of trigger that you have set up. So in this one, I'm reading out, and you can see it. It doesn't like packet 2. Why is it? I'm sorry?
Saying packets, instead of packets.txt, packets_iBeacons.
Yeah, so there we go. So it's going to sit there and it's going to keep repeating all the beacons out. Again, troubleshooting, if you do find that it's a hardware issue, this is a way to figure out if the app is working properly by simulating all of that. And you can mess with the variables, change your power levels to simulate different distances. You can actually watch an app think it's moving through an environment by playing with those values. All coming off of one device. So,
spectrum analysis, that's probably the big one. A lot of you guys, I don't know if you guys are aware, the HackerF, they released custom firmware to do sweeping like 2 weeks ago. 2 weeks ago today, I think it was. And so the HackerF sweep command is built into the Q spectrum analyzer support. So when you open up Q Spectrum Analyzer, you pick the output of the command is hackerf sweep _sweep, and it basically says take a start range and an end range and sweep as quickly as you can between those 2 points using what bin size you specify. That's the width. And essentially it becomes a pseudo spectrum analyzer.
So we're going to do 2350 megahertz to 2500 megahertz with a 40 kilohertz width.
So as to note, the smaller you make that bin size, the faster it's sweeping, the more data it's going to send, the more CPU the VM is going to consume. If your machine can't handle it, you probably need to stop it. You may have to kill it. It's, well, yeah. Isn't there a cool Mac thing?
Yeah, well, no, I don't know. How do you do the zoom in on the whole screen?
Swipe up.
Nope. Option Command plus. Nope. No, I'm not. No, Command plus is to zoom inside a window. I saw people magnifying the whole screen.
That's but anyway, so what were you telling the HackRF? The HackRF has a bandwidth of 20 megahertz, which is right at like a Wi-Fi channel. So in order to be able to get tighter resolution, we're chunking that up into smaller and smaller slices, and then we're sweeping through it at a very rapid pace. The firmware can do basically 0 to 6 gigahertz in just under a second. That's pretty fast. So when we talk about 2, 4, or 5 gigahertz, it's a lot of times.
We're less than 1/100th of a second through 2.4.
So. And this is with a non-Wi-Fi antenna. You're going to see it. Some of the visualizers, you're going to want to spend some time tweaking the gain and stuff like that in your environment. But you have the ability to do this. And this is really rough. This is still evolving.
And yeah, this is the only application publicly available that supports this feature. There is an application in this room that's being worked on. Where's Adrian? Where's Adrian?
You just called him out.
Adrian. Oh, he's right. Okay, he's not here. Wi-Fi Explorer has this feature working. And he's just working on fine-tuning some of the values. The noise floor is a little high at the moment, but he has it working with the HackRF right now.
So if you cancel out of that, if you jump to the command line, HackRF sweep tool leverages CSV outputs. It's hung.
It's buffered.
And so one of the things that, it's just a CSV output of what it sees. So if you just do, you can specify frequency range, you can specify gain you can specify your bin width. There's also one-shot mode, which is I'm going to take one shot of the spectrum and display the results.
Number of samples per frequency, yeah.
Yep. So you can output this to a CSV file and visualize it in your own way. There's a script called HeatMapper on the OVA that basically will take that, process it, and build you a color image of this over time. So.
Where's the file?
You don't have to just do it to output standard log.
Output fields.
HackRF sweep dash W.
Dash W, right.
That's fine. Just hit that. Dash width is you and your E notation.
Stop. There. All right.
But like I said, there's examples in the lab guides for spectrum analysis for doing this. And it just outputs a CSV. I will warn you, in USB 2 mode, sweeping at full rate, it can be over 20 megs a second of log file. So if you want to leave it run overnight, just understand it will fill up the hard disk on your VM. Ask me how I know. I was like, oh, I'll just let this run overnight and I'll come back, and I came back and everything was broke and it was full.
Here we go.
Well, you're outputting to a file.
I know.
But if you take out the output to a file, it will just display it in the terminal. On to GQRX, your HackerF streaming. So these are all the measurements it's taking in pseudo real time.
Adrian, you missed it. I talked about your app. So these are the values that he's pulling in to see that. His looks a lot nicer than this.
But like I said, you are free to take that output and visualize it however you want. One thing to note, and I know there's a thread going on Twitter with Adrian and Mike, these are not in DBM. These are in DBFS because we don't have a reference of what DBM is. So it's basically a dB of full scale. So what percentage of full scale that the DAC on the HackerF sees. So it's like I see analog, it translates to this percentage of full output in dB. So if you want to do it, you got to calibrate it. Like you want to calibrate the noise floor, you have to have a source to calibrate it from. The other piece to note is because the HackerF covers a lot of bands, that calibration is not consistent across all those bands. So if you're going to do 2, 4, and 5, you probably need to calibrate them individually. So do you want to show GQRX?
Yep. So GQRX, this is your simple SDR, software defined receiver. Works with the HackerF. We have a few values here. If you select HackerF1, it automatically puts in your device string for you. Input rate, 8 or 10. You don't really want to go much higher than that, especially in a VM. And then decimation is how taking those samples and then subsampling them. So if I have 10 million and I decimate it by 8, I'm going to get 1.25 million. And the reason you do that is because it's taking it in through USB and then processing it in software. So take in a lot through USB and then sample those before you process it in software. If you just take the whole fire hose, it's going to slow everything down. So if you find performance issues, hit that decimation number. The bigger the decimation, the lower the sample size.
The reason that's important, HackerF does not support sample rates below 2 million samples per second. So if you want something or you can't handle a ton of data, you're going to have to take at least 2 million samples per second. So take that in, downsample it with decimation to something that your machine can process and move forward.
Bandwidth is 20 megahertz. That's the max that the HackerF can do. You can set that to whatever you need. If you only need to see 5 megahertz, maybe you want to set it to 6. The LNB-LO, that is your offset. So if I had mentioned up converters and down converters earlier, if you want to go to 8 gigahertz with this, it clearly doesn't do that. But we can get an up converter that attaches to the antenna and takes an 8 gigahertz signal and drops it down to something that this can hear. So we can take that in. What that offset allows us to do is to offset the values that we see by the value that the up or down converter does. So that if you're taking in an 8 gigahertz signal, we can tell it to offset by 3 gigahertz. And now, if that's what the up converter does, a 3 gigahertz offset, Now I'm going to see 8 gigahertz in the top, even though I'm not tuning the hack RF to 8 gigahertz. It's actually tuning it to 5 gigahertz. But the displays are to what I'm actually going to see. Sample rate for audio and device, those are depending on what you have. If you have a 96 kilohertz audio device, set it to 96 kilohertz. Defaults are fine for that. So what this does, we can set our FFT size. I like 8192. I have a fairly powerful machine to run it in. Frame rate, it all depends on your graphics acceleration. Time span, you know, these are all the visualization options that we're going to see over here on the left. The receiver options, these are your different filters and demodulators. So if we want to hear broadcast FM, we're going to go to wideband FM, mono or stereo. If we want to listen to AM, we're going to tune it to AM. Sideband, upper or lower, for any hams out there. You have all your options. And then demodulation off is when you're not listening to audio. You don't want to hear all the static. Automatic gain control, I always keep it at fast. It just allows the software to control the gain on the device. Squelch, filter out the noise. What do you want to cut off the noise at? If you get a good signal, you can click, you can tune it in yourself. Just drop this value down to what you need it to be. If you click auto, it's going to tune it to whatever the current signal strength is. So if you're seeing something at negative 20 dB and it's shooting all over the place and you're getting noise at negative 60, and you hit auto, it's going to cut off at negative 20, not negative 60.
Let's show them.
So this is the wireless mics. This is my microphone right here. So we're not able to demodulate this because we unfortunately found out that these are digital and AES 256 encrypted. This device is not made for that. We don't have the time or probably skill set to really decode that on the fly.
So yeah.
So we're going to tune down to, anyone know any radio stations here? 91.5. So we're going to demodulate this to wideband mono.
You can hear it through the HDMI.
Oh, yeah, it's going through HDMI right now. Is there a way for us to hear that through the speakers? What's that? I'll go to audio. Yeah, it's playing it through the display port, so there we go. Touch bar. Yeah, I don't know why it's not.
Oh yeah,
I can't.
But it was enough to show that it was there.
It's not moving. Yeah. There we go. So you can see it's there. I can go and I can get stereo. So we'll turn that off now. But if you're ever somewhere and you don't have internet radio, you can tune in some FM.
So one thing to be cognizant of is, some of you may have noticed there's a line, like no matter where Ryan tunes, there's always a line kind of in the center of his band. Some people are like, my hack RF's defective because I got this line of noise no matter where I tune. That's actually part of the software-defined radio. That's the DC, basically the place where DC lines up. if you wanted to listen to like radio and that DC offset lines perfectly with the channel, it may distort the audio. But you can always click someplace else, like you see these two channels here, you can always click your mouse on that channel and tune in something that's not in the exact center of what you're looking at. And that's typically called the DC offset. I'm offsetting it enough that my channel's wide enough that I can get the signal so that I don't get that distortion. So when we're sweeping, like in Spectrum Analyzer, we're usually looking at a chunk of bandwidth that is on one side of that DC offset or the other, so that we don't artificially introduce all of that noise into.
So your GQRX is a great tool if you just need to look at some frequency really quick. If you need to build something that actually functions, new radio is where you're going to spend your time. New radio, you can see on the right side, GNU radio, I don't know, whatever you want to call it. I just call it new radio. It has all of these modules and blocks that you can piece together and connect and set values for to build demodulators, decoders, whatever you need. This right here is the same radio that we were just listening to. This is an FM receiver that I built. So
Green up their household energy use. Learn more.
You can see I have a FFT, I have a waterfall.
Delivering more than power.
I can tune up here. I made my own receiver. So
yeah,
yep.
So the file is, I think it's XML.
Yeah, it's an XML file, but it actually builds Python. So if you take one of these blocks and you go into the properties, you can see the generated code. It's kind of hard to see, but this is all Python that it spits out. So you can go in and you can take these blocks and build your own Python scripts to do this and build your own applications. And you can build GUI-based applications like this one, or you can build ones that just run in the background and output files or audio. Yeah, there are tons of different tools out there for using new radio with the HackRF. Great Scott Gadgets has all of that stuff. But really quick, I'm going to build something here. So, sample rate.
I'll talk a little bit while he's building that. One of the things that is also included in new radio is instrumentation. So radio frequencies are great, but as you saw Ryan, he could actually visualize the signals coming in. If you're making your own, you can visualize those as well, like if you need an oscilloscope or an FFT, or you need a waterfall graph or those things. Those are all instrumentation pieces. Instead of outputting it to a device like a HackRF, you can also, or in parallel, pipe it into a virtual oscilloscope and be able to look and see what's going on. One of the labs that we do, we actually are generating DFS wave signatures. And the FCC has really specific, the pulse must be this wide and must be this much time between pulses in a burst, and there must be this much time between bursts overall. And you can actually go in, generate the signal, pipe it into an oscilloscope and say, I'm going to measure, yes, this pulse is between 12 and 15 microseconds. And the gap between pulses is 1,428 microseconds between pulses. And so some of those things that are nice, that if you're like, as we're all good stewards of our spectrum, we do need to be cognizant of not transmitting things on frequencies where A, not allowed, and B, where we are causing interference. So you can always use a instrumentation scope or instrumentation sync to be able to look at what you do before you do it, to make sure you're not doing more harm than good. So.
Can you talk a little bit about the transmit capabilities?
So transmit capabilities, it's capable of transmitting all the way through its usable spectrum. There are some challenges with the are you recording me?
You're on Twitter Live.
I don't want to talk about it on Twitter Live. I'm talking about it to you. But the transmit capability is good. It's not, I mean, we're limited at 20 million samples per second. You're probably not going to be able to do Wi-Fi with this. Just setting that expectation. There's too much throughput to be able to do some of that.
So here's instrumentation right here. This is channel 1 Wi-Fi. We have a waterfall, we have the frequency, and we have a constellation view.
Yeah, so if you want to demodulate some very low QAM, whatever you want to call it, we have the ability to look at the constellation patterns that you guys want to see.
And you saw how quick I was able to build that. And that's a simple tool. There are, in this, you know, we have a whole module for Zigbee. All of these right here. Where's
the one thing I will say regarding your question about transmit, HackRF, it's not linear. So the amount of juice you get at 300 megahertz is way more than you get at 5 gigahertz. So one of the challenges is if with transmitting DFS is you need to stop transmitting. Pulses are things that start and stop very quickly. New radio, we have a thing where we actually will walk you through building a DFS signature. The challenge is actually transmitting it. HackRF today, as you noticed, most of you had to reset it between things that you did. When you're transmitting, it continues transmitting. The carrier is still in place after it sends the signal. The way most SDRs get around this is by switching from transmit to receive. It cuts it off. With DFS, because we're so limited on transmit power, you have to be very, very close unless you can stop the transmission. Because otherwise that carrier becomes kind of a noise floor of the pulse, and you can't generate enough transmit power to trigger it without stopping transmission. So
this is an issue that was open, then closed.
Now it's reopened.
It's reopened. So as soon as it is open, we've given you the tools to build it, but you can't use it just yet because someone closed the issue before it was fixed.
So I have conversations going on with the GR Osmocon developer, trying to get this issue reopened so that we can do it. There are other ways of doing it. You can use SOAPy SDR,
which is another interface. GR Osmocon is the official interface to the HackRF. It's the drivers and the tool set. SOAPy SDR is an abstraction layer that tries to control more than just one. You can control many different SDRs out there using that. So you can have an application that supports SOAPy SDR, and that instantly gives it support for all of the things supported by it.
Part of the challenge is getting something that was the front end for SOAPy's Pothos, and it's very CPU intensive. It probably wouldn't run on 90% of our laptops. New radio is fairly light.
It just generates Python scripts.
Yeah.
So.
It's a DFS is a new radio.
There is a DFS, there is not a DFS, there is a GR radar, new radio radar. It is not in this. It is so ugly to build.
You'll want to dedicate a machine to that.
I built it once, and I think there was a lot of quoting Ryan in his presentation earlier. It's not something, so this is built for academics. Radar Pulse, I tried really hard to, I don't want to say dumb it down, but I didn't really want to spend an hour teaching you guys about complex vectors with imaginary components and trying to do that. So in the lab guide for DFS, there's a very simplistic DFS pattern where we talk about how to actually generate it. And you can do it on a scope. If you plug that in directly, it will not transmit a pulse that will trip DFS. But it is enough that you can get into a scope and actually measure it and make sure that it lines up with the DFS pulses that we should be generating.
So again, we are working on getting that.
Where do they find all these?
These are going to be in a Dropbox link that will be emailed to you. And I will, in fact, I may already have it because I was having trouble getting it earlier.
So there are a number of labs. HackRF's, the HackRF sweep and the spectrum analysis is one. There's some stuff on FM, ham radio, CB. some ADSB that Ryan was nice enough to fork somebody else's project and tweak it enough so that we could show off.
ADSB, I should show that right now. That one's a fun one, and you can do some really cool stuff with it. One of the things that is really cool that you can do is if you live somewhere like I do, where there are secret military bases nearby, you can see all of the unmarked planes that are at 90,000 feet. Because when they're flying over civilians, they have to comply with stuff like that. All right, so we have connection. Second. So you can see in the terminal, we are getting air-to-air surveillance. Interesting. We're getting all sorts of planes showing up, and they're not showing up here.
It can take a little bit.
Yeah.
But there are a lot of like flight aware capable stuff. You can leverage that with the HackRF. It's probably not a good investment. You can go buy a $20 SDR that you can tie up to use with flight aware or those types of websites. A $300 SDR probably isn't the best use of that, but
For you to judge.
yeah, who am I to judge? But you can, and that's kind of the important part of being able to go through and do some of this stuff.
Yep. So this folder here, I will put up on the screen. I'll make a shortener for it, and that I can send out. I'll tweet it out.
We'll get it off. We'll get it off.
Yeah. But that is, you know, I'd be happy to. I'm gonna have some whiskey later, so when I have whiskey, I have a lot more fun with these. So if anyone wants to spend time later and has questions that wants to play with it.
So you have maker sessions where so you could have tools to play with, and these guys did an amazing amount of work to get to where we are now. Troubleshooting every one of your issues is not what they're here for, but we do have lots of labs, and as we get more, we'll just continue to get them out. You all have the tools, and so if you come up with an idea, where's Luke? To make it do something else, let's add them and share them between each other. So we're done for the day. Nothing official going on tonight. We'll see you back here tomorrow at 8:15 in the morning. And thanks, guys.